Hello everyone, good evening. Welcome back to our YouTube channel. This is the Drug of the Day series where today we'll be discussing briefly about GLP-1 agonists. So let's get started. So GLP-1 agonists, they are anti-diabetic drugs and they belong to the class of incretin system modulating agents. In this class, we have two categories. We have incretin mimetics and we have DPP-4 inhibitors. DPP is dipeptidyl peptidase 4. Okay, so under incretin modulating agents, we have incretin mimetics and we have DPP-4 inhibitors. And GLP-1 agonists, they belong to this category. They belong to incretin mimetics. Okay, now GLP-1 is a very important incretin that is released from the gut in response to the ingested glucose. Now, before moving on to the drugs of GLP-1 agonists, let's look at incretins. So several polypeptide hormones have been identified that are synthesized from the cells of upper intestine. Okay, so incretin is synthesized in the upper intestine, and these hormones, they act to modulate the carbohydrate metabolism. And among these hormones are the incretins. So the two main incretins of our body are GIP and GLP-1. This is very important. GIP is glucose dependent insulinotropic peptide and GLP-1 is glucagon like peptide. Okay, GIP and GLP. And GLP-1, which is glucagon like peptide 1, its secretion is reduced in the patients who suffer from type 2 diabetes mellitus. That's why in the patients of type 2 diabetes mellitus, we give GLP-1 agonist, because in them GLP-1 secretion is reduced. Okay. Next is GLP-1 is an incretin. It is a natural peptide hormone that is secreted in response to the food that we take. Now, incretins, they have multiple physiological effects to lower the blood glucose. So they lower the blood glucose, and they do this by stimulating the release of insulin from the pancreatic beta cells, and they also cause inhibition of glucagon release after meal. Okay, so the two main effects are they cause stimulation of insulin release from the pancreatic beta cell, and they inhibit glucagon release from the liver after we take our food. Next is, in addition, GLP-1 also slows down stomach emptying. This is very important. It slows down stomach emptying and it causes a feeling of fullness and also reduces additional food intake. And this happens because it binds to GLP-1 specific receptors that are present on the beta cells of pancreas. They also have little stimulatory effect on insulin. In insulin secretion in normoglycemic concentration. So normoglycemic means when the blood glucose level is normal. So in normoglycemic people, they have little stimulatory effect. That's why they have a very low risk of causing hypoglycemia. So this is an advantage. Now, apart from releasing insulin, GLP-1 also has other actions, which are they preserve the islet cell integrity and also decreases apoptosis. Apoptosis is programmed cell death. So it preserves the integrity and decreases its apoptosis, also promotes beta cell health, and it delays gastric emptying and reduces appetite. So these are the advantages. Then the endogenous GLP-1 is rapidly broken down by DPP-4. This is very, very important line. So this GLP-1 is broken down by DPP-4, which is dipeptidyl peptidase 4. That's why the half-life of GLP is very less. It's around 1 to 2 minutes only. So the two main strategies by which the incretin's effect can be increased in our body is by giving GLP-1 agonists or DPP-4 inhibitors. We don't give DPP-4 agonists. We give DPP-4 inhibitors because DPP-4 is the enzyme that is degrading GLP-1. Okay, so to increase the effects of incretin, we give GLP-1 agonists or DPP-4 inhibitors. Now, another incretin, we discussed about GLP, but apart from that, the next incretin is GIP, that is glucose dependent insulinotropic peptide. It also induces insulin release, but it is not the main hormone. The main one is GLP-1 only, and it is the most important one, which is related to type 2 diabetes mellitus. Next are the drugs. So the first drug of GLP-1 agonist is Exenatide, And this is the structure of exenatide. No need to remember the structure. So this exenatide, sorry, as you can see here, it is a 39 amino acid peptide. Okay, this is the N terminal and this is the C terminal. So DPP4 enzyme, which degrades GLP. So DPP4 enzyme acts here. It leaves 2 amino acid from the N terminal and then it breaks the peptide bond here. Okay. Now, it is a synthetic analog which activates the GLP-1 receptors. It is a peptide, that's why it is inactive orally. We give it via subcutaneous route. Now, after its subcutaneous injection, its plasma half-life is around 3 hours and the duration of action is 6 to 10 hours. Now, it is used mainly as an add-on drug. Okay, it is used as an add-on drug. It is not used alone for the treatment of type 2 diabetes mellitus. It is used as an add-on drug to either metformin or sulfonylureas, or it is given in combination with pioglitazone. So these 3 drugs, metformin, sulfonylureas and pioglitazones, even they are anti-diabetic drugs. So it is given as an add-on drug with these 3 drugs in patients of type 2 diabetes mellitus. Now the main benefits of exenatide is it causes lowering of postprandial as well as fasting blood glucose. So postprandial is after taking meal. So the blood glucose level after taking meal is the postprandial blood glucose level, and before taking meal is the fasting blood glucose level. So it lowers both the blood glucose level, both postprandial as well as fasting blood glucose level. It also lowers HbA1c. HbA1c is actually glycated hemoglobin. This test is done to find out the blood glucose levels, and it also lowers the body weight. Okay, so it lowers postprandial as well as fasting blood glucose levels, also lowers HbA1c and lowers the body weight. Next, the most important side effect is nausea and vomiting that occurs in around half of the patient, but tolerance later develops to this side effect. Next drug is liraglutide. So this is the structure of liraglutide. It is again a peptide. It is a 16 carbon fatty acid that is attached to a 31 amino acid chain. And this fatty acid chain, this is the fatty acid chain, it promotes its binding to albumin and limits its degradation by the DPP4 enzyme. And that is why it has a prolonged duration of action. So liraglutide is a recently developed long-acting GLP-1 agonist, and its T-half is greater than 12 hours. The T-half of exenatide was around 3 hours, and the T-half of liraglutide is greater than 12 hours, and its duration of action is greater than 24 hours. The duration of action of exenatide was around 6 to 12 hours. Okay, so that's why it is longer acting, and it can be given once daily as compared to exenatide, which is given twice daily. Okay. Now it is again injected SC once daily alone, or it can be given as an add-on drug with oral metformin or sulfonylureas or pioglitazone. It has achieved improved glycemic control in type 2 diabetes mellitus patients. Then the main side effects are nausea, vomiting and diarrhea, but they decrease over time. Then the use of liraglutide also causes weight loss. This was also seen with exenatide, and the liraglutide also causes weight loss. That's why it is being evaluated as an anti-obesity drug, not just for diabetic patients, but also for non-diabetic patients. So this is very important. Its weight loss property has been evaluated as an anti-obesity agent for not just for diabetic patients, but also for non-diabetic patients. Then it does not require dose adjustment in renal patients, in patients who suffer from renal failure, whereas in exenatide that was required. So this is an advantage here. Then, apart from exenatide and liraglutide, the other 2 drugs under this category are albiglutide and dulaglutide. Even they are long-acting agents, and they can be given once weekly. Okay, so liraglutide was given once daily. Albiglutide and dulaglutide are very long-acting drugs which are given once weekly. So this is an advantage. The latest approved GLP-1 agonist that is given once daily is lixisenatide. Okay, this is the latest approved drug. Now this was the question that came in GPAT 2013. The question was, which of the following is a GLP-1 agonist? Very simple question, and the options were sitagliptin, pramlintide, exenatide or apalristat. Now all the options that are given here, they all are anti-diabetic drugs, And the answer here is exenatide. Out of all these anti-diabetic drugs, exenatide is the only drug that belongs to GLP-1 agonist category. Now, sitagliptin is a DPP-4 inhibitor. Okay, in DPP-4 inhibitors, the drugs are called gliptins. Sitagliptin is the example, and the other example is vildagliptin. Now, pramlintide is an amylin agonist. This again is a class of anti-diabetic agents. It is an amylin agonist. So amylin is released from the beta cells of pancreas along with insulin. So in patients of diabetes mellitus, along with insulin, deficiency of amylin also occurs. That's why amylin agonists are given, because amylin deficiency occurs. And last is apalrestat. So this is a new agent here. Apalrestat is an aldose reductase inhibitors, which helps to reduce the complications of diabetes. Okay, it helps to reduce complications, and it is an aldose reductase inhibitor. So in diabetes, what happens is glucose, it is converted to sorbitol via the enzyme aldose reductase. Okay, so glucose in the presence of enzyme aldose reductase gets converted to sorbitol, which is a tissue toxin. So what we do is we give apalrestat, which is an aldose reductase inhibitor. Okay, so it will inhibit the enzyme aldose reductase, because of which sorbitol won't be formed and no tissue toxins. And sorbitol is a tissue toxin, so all the complications of diabetic neuropathy will be reduced. Now the next question is, all of the statements about exenatide are true except, okay, except is asked. So the options are, exenatide is a GLP-1 analog. It can be used for the treatment of type 1 diabetes mellitus. It can be given subcutaneously, or it decreases the glucose levels. So is exenatide a GLP-1 analog? So yes, it is a GLP-1 analog. Then next is, it can be used for the treatment of type 1 diabetes mellitus. So this is the false statement, because it is used in the treatment of type 2 diabetes mellitus. So this is important. Then it can be given subcutaneously. Yes, it is given subcutaneously because it is a peptide. It cannot be given orally. It degrades easily. And it decreases the blood glucose level. Yes, it decreases the blood glucose level. So the wrong statement here is, it can be used for the treatment of type 1 diabetes mellitus. Now the next question is, which enzyme inactivates GLP-1? This is very important. The options are endopeptidase, aminopeptidase, dipeptidyl peptidase, or carboxypeptidase. All the options that are given here, they all degrade the peptide bonds. They all are peptidase hormones. But from all these, the only peptidase hormone that inactivates GLP-1 is dipeptidyl peptidase, which is DPP-4. Okay. So let's look at the other peptidase also. So endopeptidase is the enzyme that breaks peptide bond from within the molecule, because it says endopeptidase. Okay, that's the difference between endo and exopeptidase. Endopeptidase breaks the peptide bond from within the molecule, and exopeptidase breaks the peptide bond from the end part of the peptide molecule, or the amino acid. Next is aminopeptidase. So aminopeptidase are the enzymes that breaks the amino acid chain at the N terminal of the protein chain, and carboxypeptidase are the enzymes that breaks the peptide bond from the carboxy terminal, that is the C terminal at the end of the protein chain. Okay, so aminopeptidase breaks the bond at the N terminal, and carboxypeptidase at the C terminal, or the carboxy terminal. And endopeptidase breaks the bonds that are present within the molecule, and exopeptidase at the end of the amino acid chain. And DPP, which is dipeptidyl peptidase, is the enzyme that breaks GLP-1. So yeah, thank you. I hope you enjoyed today's video and found it informative. And if you did, please like it and share it with all of your friends who are preparing for GPAT and NIPER. Also subscribe to our channel. Also, we have a free WhatsApp group where we daily post 5 MCQs related to GPAT and NIPER. So if you wish to join the group, do leave a message on these 2 numbers that are given here at the end of the slide, and we'll do the needful. Thank you.